have discussed till empty set. And we have also discussed that we can represent this empty set as like this. There is no element inside the bracket, or we can also write it as 5. Okay. Today we will be discussing about finite and infinite set. So finite set and infinite set. Here, if we will focus on the name, the finite set. So here the name is saying all about itself. Finite means having a certain number of elements. So suppose if we are saying there is a set A containing few elements like 1, 2, 3, 5. So this is an example of finite set. Here we can represent number of elements in set A is equals to 1, 2, 3, 4. 4 elements are there in set A. This is how we will represent the number of elements in any set. This one is representing number of elements. In set A is equals to 4. We will count the number of elements. One element, the second element, the third one, and the fourth one. So here total 4 elements are there. Similarly, if we will take one more set, let's say set B, and if we will have the number of elements as like 2, 4, 6, 8, 10, 12, 14, like this. So here we can write how many number of elements are there. Can you say? Number of element in set B is equals to
7.
Yeah.
7.
How many? Yeah. It's 7, right? 1, 2, 3, 4, 5, 6, and 7. Total how many elements are there? 7 elements are there, right? Is it clear, Lena?
Yes.
Yeah. Similarly, we will count the number of elements. Now, suppose we are having one set of natural numbers. Set of natural numbers. So we know natural number are counting number which starts from 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just all the counting number till infinity are natural number. So if we will list down all the numbers, all the natural number. So 1, 2, 3, 4, 5, 6. It will be just continuing. Okay. It will just keep on going till infinity. So it is not possible to write all the numbers on this board, right? So here we can say that this set is a infinite set. Why? Because we are not able to count it. Here, if we have to write the number of elements in the above set, then the number of elements are infinite. Okay, so finite set means where we can count the number of elements, where like number of element is countable. 10 elements are there, 12 elements are there, like this 7 elements are there. You will be able to count it. Okay, but infinite sets are sets where we will not be able to count the number of elements. So set of natural numbers, set of real number, these are the example of infinite set where infinitely many elements are there. All right. Now we will talk about equal set. So two sets are equal when they have exactly same element. So suppose we are having a set A, 1, 2, 3, 5, and a set B where the elements are 5, 3, 1, 2. Now, you know that order doesn't matter. We can write the sequence of the number here and there, but the set is same. So here set A is having a element as a 1, set B is also having 1, set A is having 2, set B is also having 2, set A is having an element 3, set B is also having 3, and set A is having the last element as 5, set B is also having the same element. So only we have to match if all the elements are same or not. It can be sitting here and there, left and right doesn't matter. Okay, if all the element of set A are present in set B, then we can say that set A is equals to set B. Okay, is it clear, Lina?
Yes.
Let's do one more question together. So if we are having, for example, a set A where the element is just 0, and one more set we are having, one set B where the elements are, let's say, yeah, it's written in set builder form. So set of all x such that x square is equals to 25. So yesterday we have discussed how to write a set from set builder form to roster form. So here we will be, let's write it in roster form because that is simple to understand. So when we will write this set in roster form, it will be, can you tell me what will be the element of the set? Which number we will
5.
take? Yeah. What you said?
5.
Yeah. Perfect. It's 5. And any more number like which we will do is squaring and it will give 25?
No.
Yeah. It's -5, right?
Yeah.
Yeah. When we will do square of -5, we will again get 25 million. Yeah. Positive 25 we will get. So these two are the only number which after doing the square will give us positive 25. So set A is having an element 0 and set B we have written in roster form, the easier form, that is 5 and -5 are the element. Now we have to check whether these two sets are same, equal or not. So what's the definition of equal set says? Each and every element of A must be present in set B. So here 0 is there, but in set B there is no 0, right?
Yes.
So we can say set A is not equals to set B. Okay.
Okay.
So we have discussed about finite and infinite sets. We have also discussed about equal set. Now we will be discussing about subsets. So here we are going to start the concept of subsets of any set. Okay, but before starting the concept of subset of any set, let's recall the previous class one concept where if set A is having few element as 2, 4, 6, then we can write 2 belongs to set A. 4 belongs to set A. Similarly, 6 belongs to set A. This is the sign of belongs to. And if we have to write 8, does it belongs to set A or not belongs to set A? So 8 is not there in set A. So we will say 8 doesn't belong to set A. So this concept we have already discussed yesterday. Today we are going to start subset. So the definition of subset says if we are having two sets, let's say suppose we are having set A which can be taken as anything 2 and 4, and set B which can be taken as, let's say, 1, 3 and 7 4, 2, 9. Yeah, these two sets we are having. And here set A is having two elements. 2 belongs to set A and 4 belongs to set A. We can write it like this. Let me write it. Here 2 belongs to set A and 4 also belongs to set A. Similarly, for set B, if we will focus on set B completely, we can say 1 belongs to set B, 3 belongs to set B, 7 belongs to set B, and element 4 from the set B, it belongs to set B. Similarly, 2 belongs to set B and 9 belongs to set B. Now, we have to check whether 2 belongs to set A and does 2 belongs to set B also or not. So, one element of set A, does it belongs to set B also? Now, another element of set A, does it belongs to set B also? If like this, all the element of set A belongs to set B also, then we can say A is a subset of set B. So here we can say 2 belongs to A and 2 belongs to B also. That means 2 is an element which is present in set A and it is present in set B also. Similarly, 4 is an element. It is present in set A and it is also present in set B. So we can say A is a subset of B. This is called subset. Or this is also called A contained in B. Contained in B. Make sure all the element of A must be there in B. If any element of A is not there in B, then we can say A is not the subset of B. Let's take one example. So if we are having A as 1, 3, 5, and if we are having B as 7, 9, 5, 11. All right. Here we can say, if we will look at the sets, both the sets carefully, we can see 1 belongs to A, but 1 doesn't belongs to B, right? Similarly, 3 is there in set A, but number 3, the element 3 is not there in set B. 5 belongs to set A and 5 belongs to set B. Only one element is same in both the sets, but other elements are not same. So we can say A is not subset of B. So this is the sign of subset. This is the sign of subset. And if we have to say it's not the subset, we will cut it. Okay? Are you getting it?
Yes.
So this is how we will define subset. Let's do few questions. And yes, one more thing, 5. 5 is empty set. We represent empty set by either just a curly bracket or by 5. So 5 is a subset of every set. So if we will say, here we can say 5 is a subset of A also and 5 is a subset of B also. If it is written like that, that 5 contained in A and 5 contained in B, both are true statement, because 5, that means nothing. It's a subset of every set. Okay?
Okay.
Let's do some questions from subsets. Okay. So, we are having A as 1, 3, B as 159, C as 1, 3, 5, 7, 9. and few fill in the blanks questions are there. 5 dash B. Another one is A dash B. Third one is A dash C. And the fourth one is B dash C. Here we have to fill the blank with either this sign, that is the subset sign, or this sign, not the subset. Okay, let's fill it. So the first one, now only we just discussed 5 and B. So will it be subset of B or not the subset of B?
It will be the subset of B.
Exactly, because 5 is a subset of every set. So 5 is a subset of B. Now let's go to the next one. A and B, we will match. All the element of A is present in B or not. Let's match it. A is a subset of B or A is not a subset of B?
It is not a subset of B.
It's not. Exactly. Yeah. Next one, A is a subset of C or it's not a subset of C?
It is a subset of C.
Exactly. It is subset of C because every element of A is present and it's sitting in C also. Let's do the fourth one. B is a subset of C or B is not a subset of C?
It is a subset of C.
Exactly. B is a subset of C because 1 is there in B, 1 is there in C. 5 is there in B and 5 is there in C. 9 is there in B and 9 is there in C also. So if all the element of B is there in C, then B is the subset of C. Let's do few more questions from here, quite trickier questions. So if we are having A is equals to 1, B is equals to a set like this, and C is equals to 1, 2, 3. Now there is true false question. Okay, two questions are there. B is a subset of C and A is a subset of C. We have to say whether the first statement is true or false. And also we have to say whether the second statement is true or false. So can you tell me first one, is it true or false?
True.
Yeah, that's true because each and every element of B is present in C. Next one, A is a subset of C. Is it true or false?
True.
It's not true. Okay. Why? Because here A is having a set A is having an element 1. Now only just before starting the concept of subset, we discussed that whenever we are having a set and elements are there, we can write 1 belongs to A, right? This means one element which is 1 belongs to set A, right? Similarly, if we will focus on C, we can say that, let's write it. If we will focus on set C, we can write as an element, this one belongs to C. Similarly, an element 2 is an element which belongs to C, and 3 is an element which belongs to C. So see carefully here, we cannot separate this curly bracket from this one. Okay, this is complete. If exactly same thing you are having in one, you are having in the first set, then and only then we can say the first set is the subset of C. Let me explain it again. So here only one belongs to A. Okay, an element is there which is just one. It belongs to A. But when we are going to search in C, that one is not alone. It is just a singleton set. Okay, that belongs to C. So both are not exactly same. Are you getting it?
Yes.
So since both are not exactly same, hence we can say set A is not a subset of set C. It has to be exactly same. If 2 belongs to A, 2 must belongs to C. If 3 belongs to A, 3 must belongs to C. Then and only then we can say A is a subset of C. Okay. One few more questions we will do like this, then it will be more clear to you. So here this statement is completely false. It is not true. Let's do few more questions like this only to clear the concept. So if we are having, for example, A, which is equals to 1, 2, and then a set 3, 4, 5, like this, then we have to say which of the following is incorrect or correct. So here the first one is the first one is 3, 4 is a subset of or contained in A. The second one is 3, 4 like this belongs to A. The third one is 1 belongs to A. Let's say which one is correct or which one is not correct. If any one is correct, we have to give the reason why it is correct. If anyone is not correct, we have to give the reason why it is not correct. So what I said, the definition of set says that let's focus on set A. A is having these elements 1, 2, 3, 4 like this, and then 5. So here 1 belongs to A. Similarly, 2 belongs to A. Now please don't separate 3 and 4. Okay, it's already combined and we will treat it as a single unit. So let's write it together. This also belongs to set A and 5 belongs to set A. These are the element of set A. Okay. Now, if we will be having another set whose elements are exactly same as element of set A, then that set will be the subset of set A. Okay. So let's focus on question number 1 only for now. So if we will focus on 1, there is a set A, let's say X, whose elements are 3. We can write 3 belongs to X. And we can also write 4 belongs to X. Now, if exactly same element belongs to A, then and only then we can say that X is a subset of A. So see, 3 belongs to X. Does 3 belongs to A also?
No.
Not at all. So this way we have to identify it. Okay, 3 belongs to X, but 3 doesn't belongs to A. 4 belongs to an element. An element 4 belongs to X, but 4 doesn't belong to A. And hence the given statement X is a subset of A is incorrect. Why? Because 3 is an element of X, but 3 is not an element of A. 4 is an element of X, but 4 individually is not an element of set A. Okay, let's do the next one. So the next one, let's say there is a set A whose elements are given like that. So we can write this 3, 4 together belongs to, okay, let's name it B only because A already we are having. So there is a set B having an element 3, 4 together. Okay, a set 3, 4 together. So 3, 4 belongs to set B. Now let's check the same thing belongs to set A also or not. So does it belongs to
Yes.
set A also? Yeah, it belongs to set A also. Then and only then we can say that B. Okay, here it doesn't say that subset. It says that this belongs to A. So yeah, it belongs to A. So we can say this is just a second. Here, let me check whether I have written the question properly or not. Here, instead of this one, if this will be there like this, like 3, 4 belongs to A, then it's correct. Okay, because yes, that is an element of set A, and this statement is correct. Similarly, if we will go to the third question and we will see 1 belongs to A. So, is there any element 1 which belongs to set A? Can you see? Is there any element 1 which belongs to set A? Yes, 1 belongs to set A. Hence, we can say this one is also correct. All right. So have you understood the difference between how we will analyze whether any given set is a subset of another set or not? Let's do a few more questions. So A, we were having 1, 2, 3 and 4 was together, and then we were having 5. And another example can be, suppose we are having 1, 2, 5. This one contained in A. Another one can be 5 contained in A. So can you tell me whether the first one is it correct or not correct? And if it is correct, why? If it is not correct, why it's not correct?
It is correct.
The first one is correct, right?
Yes.
Right, Lena?
Yes.
Yes. Why? Because there is a set having an element. If we will say there is a set X is equals to 1 to 5, then we can say 1 belongs to X. Then we can say 2 belongs to X. Then we can say 5 belongs to X. And we are also having 1 belongs to A, 2 belongs to A, and exactly the same element 5 belongs to A. Hence, set X is set X is a subset of set A. Similarly, phi is a subset of A. Yes or no? So we know phi is a
Yes.
subset of all the sets. So this is also correct. All right. Let's do the next one. Few more questions like this only. So suppose we are having the first example as 2, 3, 4. And we have to fill the blank with whether it's a subset of the given set or not. So 1, 2, 3, 4, 5. Next one. A, B, C. Whether it's a subset of the given set, yes or no. We have to just give the symbol over here. The next one is X such that X is a student of class 11 of your school. Dash X such that X is student of your school. So if we will focus on the first one, we have to fill the blank with either this contained in subset sign or not the subset sign. So the first one, is it the subset of the left one? Is it the subset of the right one? Yes or no?
Yes.
Yes, exactly. Because every element is present in the right hand side set. So we will say yes, it's a subset. Okay, and this is the sign of subset. The next one, is it the subset or not?
No.
No, it's not the subset. Third one, X is a student of class 11 of your school. If I will make the list of class 11 student of your school. And another one, I will make the list of all the student of your school. So all the student of your school, that list will contain the name of the student of class 11 also, right?
Yes.
Yes. So third one, is it subset or not the subset?
It is a subset.
It is a subset, exactly. The fourth one was X such that X is a circle in the plane. Dash X such that X is a circle in the same plane with radius 1 unit. So are you getting it? Whether it's a subset or not a subset?
Yes, it is a subset.
Yes, it's a subset. Let me explain it. Let me give the clarity. Okay. So here the left hand side part, it's given in set builder form, and it says subset, like it says the set of all X such that X is a circle in the plane. Now, when we are talking about the circle in a plane, the circle can be teeny tiny circle, or the circle can be a very large circle, or the circle can be like this, or the circle can be anything like this. Here radius can be 0.5 centimeter, radius can be like 0.4 centimeter, radius can be 2 centimeter, radius can be 3 centimeter. So whenever we are drawing a circle, I will tell you just draw a circle. So you will draw any circle by taking the length of the radius as anything. 5 centimeter, 6 centimeter, 8 centimeter. You will end up drawing a circle having radius anything. Maybe you will draw a bigger circle, or maybe you will draw a teeny tiny circle. Okay. This is the set. We are having all the type of circle over here. Smaller circle, bigger circle, bigger circle, bigger circle. Okay. Now on the right hand side, we are having circle which is having radius 1 unit. So we can see a circle having radius only 1 centimeter. So here the same size of circle is there. Just having the radius 1 unit or 1 centimeter, you can say. Exactly same circle, radius 1 centimeter. So left hand side, all the element of left hand side, is it present in the right hand side? Yes or no?
No.
No. Exactly, because on the left hand side, a lot of varieties are there. And on the right hand side, only one particular measurement is there. So all the element of left hand side is not present on the right hand side. And hence we can say it's not a subset. Okay, circle in X, the set of all X such that X is a circle in the plane. Randomly, any circle in the plane is not a subset of the set of all X where the circles are having 1 unit radius. Are you getting it?
Yes.
Yes. So this way only we will analyze it, whether any given set is a subset or not. Okay. Let's move to the another part. Yeah, intervals. So we have discussed about subsets. I hope you have understood about subsets. Now we will be discussing about open interval and closed interval. Okay, what exactly is the meaning of this open interval and closed interval? So let's focus on open interval. Open interval means whenever we are representing any, suppose I am giving a smaller bracket, and in this smaller bracket I am writing two numbers, okay, like 3 and 8, like this. So this is called open interval. Whenever we are representing any we will represent two numbers in an interval, and what exactly is the meaning of this, I am coming to that. So the meaning of this is we are taking all the numbers in between 3 and 8. So in between 3 and 8, what are the numbers, the integers which are coming? 4, 5, 6, 7. Okay, so this one is representing, we are taking all the numbers in between 3 and 8. If there is a smaller bracket, the smaller bracket is representing the open interval. And what is the meaning of open interval? That it will contain all the element in between the end point. So if 3 is the end point and 8 is the end point, you have to list down all the element in between that. So in between 3 and 8, 4 is there, 5 is there, 6 is there, 7 is there. That's it. We will not touch 8. Similarly, we will not touch 3 over here. And what is the meaning of closed interval? So similarly, if we are having a rectangular bracket like this and the same number 3 and 8 are written over here, then the meaning of this one is 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, and 8 is there. So just because of the bracket, we are including the endpoint and excluding the endpoint. This is called open interval. where a smaller bracket will be there. Whenever you will see smaller bracket, you have to understand, okay, the end point is not included and everything in between that is included. Whenever you will see the rectangular bracket, you have to understand that yes, the end point is also included. So if I will write here 2, 5, then we have to understand, okay, 2 is also there, included due to this bracket. Then 3 is there, then 4 is there, and yes, 5 is also there. Suppose one of the bracket is rectangular bracket and another one is that's a smaller bracket, then what we will do? If 2 is there like that and 5, and after 5, a smaller bracket is there. This is different scenario, okay? Till now you have done the order of operations and all, where you have learned that we will use only one type of bracket. The smaller bracket open, smaller bracket close. The curly bracket open, curly bracket close. Rectangular bracket open, rectangular bracket close. But here we will mix and match the brackets whenever we are defining the intervals. Okay. So whenever we are having 2 and 5 like this, let's do it separately. Whenever we are having 2 like this and 5 smaller bracket, then when this smaller bracket is representing 5 is not included and the rectangular bracket is representing 2 is included over here. So the meaning of this is 2 is there, 3 is there, 4 is there, but 5 is not there. Why 5 is not there? Because of this smaller bracket. So whenever we have to, there are two different type of scenario: open interval and close interval. It can be combination of open and close interval like this also. So you just have to understand, whenever this sign is there, it means end point is not included. And whenever this sign is there, then you have to understand that here end point is also included. Are you getting it?
Yes.
So it can be a lot of different possibility can be there. Okay. It can be, suppose 2 like this and 5 like this. Then what we will write, Lina?
3, 4, 5.
3, 4, 5. Well and good. Okay. Perfect. So this is how we will define the open bracket and close bracket. Now, whenever we are having a set in set builder form, most of the time here open and close bracket things, like we get the same thing over there also. How we get the thing, like let me give one example. Suppose we are having a set A which consists of the set of all x such that x belongs to R and x lies between -5 and 7. This is a set, okay, which is given in the form of like set builder form. So the set is defined like this. Here, if we will look at this set closely, then we can say x is larger than -5. It is larger than -5. It is not -5. It has to be greater than -5. So greater than -5 can be -4, -3, -2, -1, 0. And also one more condition is there, x is smaller than or equals to 7. So this inequality represent is smaller than, either is smaller than or equals to. So if we have to list down all the element of this set, we will be listing that x is larger than -5. So we cannot take -5 over here. Here -4, -3, -2, -1, 0. After that, 1, 2, 3, 4, 5, 6, and we will also take 7 due to this equality sign. And how we will write it in interval notation? So in interval notation, we can write it -5 is not included, the smaller bracket, comma, 7 is included, the rectangular bracket. Are you getting it?
Yes.
Similarly, let's do some questions from here. So suppose we are having set of all x such that x belongs to R, and here -4 x lesser equals to 6. I'm writing few sets over here, and you will be telling me what will be the interval form for the given set. So the second one is x such that x belongs to R, and here -12 x and then -10. The third one is set of all x such that x belongs to R and 0 is smaller than or equals to x and x is less than 7. The fourth one is x such that x belongs to R and 3 x 4. Okay, so now tell me what will be the interval form. Okay, for the first one, what will be in interval notation? What can be written over here?
A small bracket -4 and
Smaller bracket -4 and then
and
6
big bracket.
bigger bracket, right? Because 6 is included over here. Equality sign shows that 6 is included in this set. All right. For the next one,
Small bracket -12 and a small bracket -10.
yeah. -10 is smaller bracket close. Perfect. Next one,
Big bracket 0, small bracket 7.
yeah, the bigger bracket 0 because 0 is included over there, and then 7 and then the smaller bracket close. Similarly, the last one,
Big bracket 3 and big bracket 4.
yeah, big bracket 3 and then 4 big bracket close. Perfect. So this is how we will represent the given sets in interval notation. And open interval, close interval. Open interval means end point are not included. Both the end points are not included. And close interval means both the end points are included in the set. Okay. So we have discussed subsets. We have discussed this one. Now next topic is power set. We will be discussing power set, but before that, can you let me know when you are having your exam, the upcoming exam of yours?
It's in 2 weeks.
It's in
2 weeks.
2 weeks. And what are the topics which will be there in your exam? Sets are there.
Yes, sets are there.
Sets are there. And what else?
Relations and functions.
Sorry.
Trigonometric functions. Relations and functions.
Okay, relations and functions are also there. And what else? Only these 2 chapters are there. Yeah, Lina, only these two chapters are there in your upcoming test. Am I audible? Are you there?
Hello?
Yeah. Am I audible? Can you hear me? Can you hear me?
Hello?
Yeah. Can you hear me? Am I audible?
Yes.
So
Yes.
sets are there, relations and functions are there, and what else?
Trigonometric functions and principle of mathematics.
Okay, trigonometric function is there and principle of mathematical induction is there, right?
Yes.
All right. So are you able to solve the questions from sets?
Yes.
Okay. So at first we will be continuing the set and we will be finishing it. Then we will move to which topic, which the topic which seems quite difficult to you. What is that? Which topic you want to discuss after this?
Trigonometric functions.
Trigonometric functions?
Yes.
Okay. Okay, so we will be discussing trigonometric functions after this. Okay.
Okay.
Okay. So just let's continue with just one more concept, that is power set. You will be able to solve the whole exercise by yourself. Okay. So the last of the concept, power set, let's discuss it. After that, we will wind up the session. So let's continue. So the next one is power set. So suppose we are having set A, which is one having two elements, 1 and 2. And if we will list down all the elements, like if we will list down all the subset, all possible subset of this set, then those collection of all possible subset of the given set will be the power set. So if any set X is there and if 1 is there in X, it is a subset of set A, right? We know
Yes.
if any set Y is there and if it is having only one element 2, then this is also a subset of the given set A. What exactly we are doing? We are listing down all the possible subset of the set A. Okay. Phi is a subset of every set. So phi is also a subset. Next, if any set B is there and having exactly same element 1, 2, then we can say B is a subset of set A because all the element of B is present in set A. So B is also a subset of set A. So these are all the possible subsets of set A. And if we will list down all the possible subset of set A, that is 5, 1, 2, and 1 and 2, this is called the power set of this set A. So this is how we will write the power set of any set. Okay. Here The set A was containing two elements, 1 and 2. Two element. Number of element in set A was 2. Therefore, we will get 4 element in power set. How we are getting 4 element in power set? So whatever will be the number of element, just 2 to the power this one. And this is giving 4. And here you can check 1, 2, 3, 4. 4 elements are there in the power set. If the number of set in set, suppose we are having set, let's say Z, and it is having 1, 2, 3 element. 3 elements are there. Then its power set will have 2 to the power 3, that means 8 element. Okay?
Yes.
Are you getting it?